We're going to go ahead and take a look at chapter 6.2.35. We're going to answer binomial probability questions. In this case here, flights on a certain route are on time 80% of the time. Suppose 25 flights are randomly selected and the number of on-time flights is recorded. So this is a binomial probability distribution. It is because it's an experiment because there are two outcomes, either it's on time or not on time. Each trial, where trials are independent, and the experiment is performed a fixed number of times, and the probability of success is the same for each trial. That goes back to our definition. So now answering this question, what's the probability that exactly 15 flights are on time? What we have here is we have some important information that needs to be recorded on here. Given how we calculate probabilities for binomial experiments, we know we'll be conducting this 25 times, so there's 25 trials. Our probability for success is 0.80, meaning that 80% it's on time, and we're trying to calculate here the probability that x is equal to 15, that 15 of those flights are on time. And the way we do that, you can use StatCrunch to do this. Stat calculator binomial. And then we're going to put, we knew that we're going to do 25 trials. Success is 0.80. And we want exactly equal to 15. Compute, and you get 0.001177695 or 0.012 if you're going to round that. So that's how you would do it with your calculator there. 0.012. In this case, 3 decimal places, 4 decimal places was 0.0117. I think that was the answer there. 078. So we have 8. So what about so in 100 trials, we would in 100 trials of this experiment is expected about blank to result in exactly 15 flights being on time. Expected about, what you do is you're going to do 100 times, because this is the probability, 0.0118. So we're looking about, it's expected about 1 time. So it's expected about 1 to result in exactly 15 flights being on time, because this just turns out to be 1.18, so about 1 time. Now in this case, what is the probability that x is fewer than 15? What do we get on there? Again, I would just turn that to less than, and now we get 0.00555. And so again, to 4 decimal places, you get 0.0056. So that's how you would do these problems. At least would be probability x is greater than or equal to 15. You would change that. And in this case, you would use the between probability 13 inclusive. And so then you would get that. And the way you would do that, again, you would use the between one to do that problem there. You would put a 13 and 15 in that case. Compute, and you have your answer there.